Hi everybody, Mrs. Pesic here. We are looking at section 8.5, part 2. Remember, 8.5 is all about solving equations, and so far on part 1 you learned about solving linear equations and rational equations, and you also learned how to solve quadratic equations by factoring, taking square roots, and quadratic formula. So what are we going to be doing in this second part, part 2? We're going to be solving quadratic equations by completing the square. We're going to solve higher order polynomial equations, and we're going to solve absolute value equations. So let's take a look at, first of all, what is a perfect square trinomial? So x squared minus 8x plus 16 is a perfect square trinomial because it can be factored into a binomial squared. Namely, in this case, x minus 4 quantity squared. Let's do a quick little test of that. If I take x minus 4 times x minus 4, I would use FOIL here and I'd get x squared minus 4x minus another 4x is minus 8x. And then my last terms would be plus 16, which is exactly what we have here. Our next example right here is x squared plus 12x plus 36. That's another example of a perfect square trinomial. And that one could be factored into x plus 6 quantity squared. All right, let me slide this over a little bit, all this stuff out of the way. And I've got one more example of a perfect square trinomial here. It's x squared minus 14x plus 49. This one also factors into a binomial squared, and it would be x, can you guess? It would be x minus 7 quantity squared. So what exactly makes up a perfect square trinomial? Well, I think the idea is that if you take this middle term, whatever it is, or middle coefficient, if you will, and take half of that, so if I take half of this, I would get negative 7, and I square the negative 7, if that gets me this last number right here, then that's the recipe for a perfect square trinomial. So let's practice that. Let's just say, what if I had x squared minus 18x? What would I need to add to that? What would I need to have as my constant for this to be a perfect square trinomial? Well, again, you would have to take this coefficient on the x term, take half of that, which would be negative 9, and square that. And so really, if we had a plus 81 here, then we would have a perfect square trinomial that could factor into x minus 9 quantity squared. All right, so let's go back and take a look at how we're going to use this idea to solve quadratic equations. So if I wanted to solve this quadratic equation by completing the square, I guess the first question I would ask myself is this trinomial right here a perfect square trinomial? Does it fit that pattern? If I take negative 10 and divide it by 2, I get negative 5. If I square that, well, that's not minus 1. So that's a little bit of a problem, but not too much of a problem, because all we're going to do is we're going to get rid of that minus 1 that's kind of messing things up by adding 1 to both sides. So we're going to have x squared minus 10x equals 1. But notice I'm going to leave a little room here for me to add the constant term that's going to make a perfect square trinomial. So I'm going to take half of negative 10, which is negative 5, and I'm going to square that. And when I do that, I end up getting positive 25. So I have to add 25 here to make a PST, perfect square trinomial. But I just added 25 to one side of my equation, and so now my equation is out of balance. I'm going to have to add 25 over here also. So I have plus 25, and I've got to add 25 over here. Now my equation is in balance. So at this point, we want to write this PST, this perfect square trinomial, as a binomial squared. So in order to do that, we're going to write x plus a number quantity squared. what number should it be? Well, guess what? Here's your clue. This number right here is what's going to go in right there. So I'm going to have x minus 5, and it's going to be quantity squared. So I just rewrote my left side of my equation. That's the perfect square trinomial rewritten. And on this side, I have equals 1 plus 25 gives me 26. All right, at this point, we're now solving this just like you learned in the 8.5 part 1 lesson. We need to take the square root of both sides of the equation. Don't forget, when you take the square root of both sides of the equation, you're going to have two solutions, a positive and a negative. And the square rooting and the squaring are going to cancel each other out on the left. So I'm going to have x minus 5 equaling plus or minus the square root of 26. I guess I didn't need the parentheses here. I can just write x minus 5 equals plus or minus 26. And to finish this problem up, I'm just going to add 5 to both sides of the equation. And I'm going to put that 5 in front of the plus or minus. And so these are my two solutions, 5 plus square root of 26 and 5 minus the square root of 26. All right, so those are my two exact solutions for this, well, I guess we can plug them back into the original equation and show that they are going to work. All right, but we're not going to do that right now. So let's try this next example. We are again solving by completing the square. However, why does this one look different than any of the other perfect square trinomials that we've looked at? Well, what I want to highlight to you is this had a leading coefficient of 1, which came from this equation, and in all of our examples here, the leading coefficient was 1, leading coefficient was 1, leading coefficient was 1. So if we do not have a leading coefficient of 1, like in this example, that's going to be a problem. So we're going to have to get rid of that. Put this out of the way. Okay, so we're going to have to take care of that issue by dividing, in this case, dividing everything by 2. And I do mean both sides of the equation. So now I have x squared minus 5 over 2x minus 1 over 2 equals 0 over 2 is 0. So at this point, I want to solve by completing the square. I don't think that this left side is a perfect square trinomial. Let's check it. If I took half of negative 5 over 2, that would be negative 5 over 4. And if I square negative 5 over 4, am I going to get negative 1/2? No, does not look so good. So I am going to have to get rid of the negative 1/2, just kind of gumming up the works here. So I'm going to add 1/2 to both sides of the equation. And so now I have x squared minus 5 over 2x. I'm going to leave some room to complete the square, equals 1/2. Our strategy, again, is to take half of this middle coefficient, so half of negative 5/4. I'm sorry, half of negative 5/2 is negative 5/4, and then I'm going to square that to find the number I'm going to add right here, and that turns out to be positive 25 over 16, because 5 squared is 25, 4 squared is 16. So again, I can't just add 25/16 to the left side without adding it to the right side also. So I'm going to have to add 25/16 here as well. All right, and so let's clean this up. We've made a what? Perfect square trinomial. So that means this is going to be a binomial squared. And this binomial is going to be, x. And then remember, our little clue is this is what goes right in here with it. Right? Got half of the negative 5/2. So I need an x minus 5/4 quantity squared equaling, all right, well, we better get a common denominator over here. It's going to be 8 over 16 plus 25 over 16, and that's going to give us, that looks like 33 over 16. All right, and then at this point, we're solving for x. And so now we're solving by taking square roots. So I got to take the square root of both sides of the equation. Don't forget, when you're doing that, taking the square root, you must have plus or minus. All right, and so the square rooting and the squaring on the left are canceling each other out. So I get x minus 5/4 equaling plus or minus square root of 33 over square root of 16. But I can write square root of 16 as just 4. And so my last step would be to add 5/4 to both sides. And I'm going to put that 5/4 in front of the plus or minus. And so I get 5/4 plus square root of 33 over 4 and 5/4 minus square root of 33 over 4 as my two solutions for this quadratic equation. Again, you can plug them into our original equation, which is this guy right here, and see if they work. All right, let's move on to other things. Let's talk about solving polynomial equations of higher degree. For this particular example, if we're trying to solve x to the 4th minus 81, what you can do is you could say, I'm just going to add 81 to both sides, and that would get me x to the 4th equaling 81, and then I can take the 4th root of both sides, but with the 4th root I would need plus or minus, and then that looks like it's going to be x equaling plus or minus the 4th root of 81. Isn't that 3? So I would have plus or minus 3. But what we're going to learn in this class is that if you have a degree 4 polynomial equation, degree 4 polynomial equation must have 4 roots. That means 4 solutions. Well, we only found 2 solutions. We found 3 and negative 3. So let's think of a different way than what we just did. All right, I'm just going to get rid of this. Let's start fresh. Instead of doing that, since we only found 2 solutions, there must be 2 more somewhere. So I would say, can we factor this? Is this factorable? Question mark. And yeah, it's a difference of 2 perfect squares. What do I need to square in order to get x to the 4th? I would need to square x squared. What would I need to square in order to get 81? I would need 9. So that means that I can write this. This is like my u squared minus v squared. Oh, I'm sorry. I should say 9 squared, right? So I can take x squared, quantity squared, minus 9 squared. And I can say this is x squared minus 9 times x squared plus 9. And again, this is equal to 0. So if I have 2 things being multiplied together to give me 0, one of them had to be 0. So we're going to set each of these equal to 0 to solve. And actually this one over here, we really could factor further, couldn't we? And we'll have x plus 3 times x minus 3. And then times the x squared plus 9 equals 0. Now if I set this equal to 0, this equal to 0, this equal to 0, I get, just put this down a little bit, I get that x is going to equal negative 3, x is going to equal positive 3, and if I set this guy equal to 0, I get x squared plus 9 equals 0. I subtract 9 from both sides, I get x squared equaling negative 9. And if I take the square root of both sides, you're like, wait, there's a negative under the radical. And, well, that's true. But my 2 other solutions would be plus or minus the square root of negative 9. And we're going to talk about what do we do with that. These would be not real numbers, but what's called imaginary solutions. All right, and so we'll talk about that, but those are our other 2 solutions. So right now, let's just leave it as our solutions are negative 3, positive 3, square root of negative 9, and negative square root of negative 9. All right, so those are our 4 solutions, and it turns out on these solutions, 2 of them are real. These guys are real solutions, and 2 are imaginary. These guys are imaginary solutions, but we will talk more about that when we get to chapter 2. All right, let's take a look at this example here. X to the 4th plus 5x squared minus 36 equals 0. Let's try and solve that. So in this case, for this, I notice that this is an even integer. This exponent is an even integer, and this exponent here is half of that degree. I'll say even degree, half of that degree, and then this here is just a constant. And that means it may be possible to factor. May factor by using product solve. So let's test it out. So if I want to factor this, the product is 1 times negative 36, that's a negative 36, and the sum is the constant, the coefficient on the x squared term in this case, so that's 5. And so what two numbers will multiply together to give me negative 36 and add up to 5? Get this guy out of the way. Okay, so the two numbers, let's see. 36 and negative 1, nope, that adds up to 35. 18 and a negative 2, nope, that adds up to 16. Let's see, 3 goes in how many times? 12 times, nope, that adds up to 9. 4 goes in 9 times. I think that's our winner. So I want 9 and negative 4. So I'm going to take out my middle term, which in this case is 5x squared, and I'm going to replace it with two things that are going to add up to that, namely 9x squared and negative 4x squared. So I'm going to write x to the 4 plus 9x squared minus 4x squared minus 36. And I'm going to factor by grouping. I can factor out an x squared. And what do I have left? X squared plus 9. And I'm going to factor out a minus 4. And I'm going to have x squared plus 9 again, equaling 0. So my final factored form, well, maybe not final, but x squared minus 4 times x squared plus 9 equals 0. All right, and so in this case, we can factor this one further. This factors into x plus 2, x minus 2. Can't do anything with this guy. X squared plus 9 equals 0, and then I would set everything equal to 0. Here I'm going to get x equals negative 2. Here I'm going to get x equals positive 2. And here I'm going to get the same thing I had before. I'm going to get x squared equaling negative 9. I'm going to need to take the square root of both sides, plus or minus, and so I get x equaling plus or minus the square root of negative 9. So those are going to be my 1, 2, and this is going to really be 3, 4 solutions, right? Square root of negative 9, and negative square root of negative 9, which by the way is not the same as 9. So those are going to be my, my 4 solutions. Right, these 4 that I've circled, and that will make sense because this was what degree? This was a degree 4, so it should have 4 solutions. And we found all 4. 2 are real, 2 are imaginary. All right, let's take a look at one last thing on this 8.5 part 2 video. This one is solving equations with absolute values. So I think you learned how to do this in Algebra 1, but let's review. Remember that x minus 4 in an absolute value equals 7 means that x minus 4 is 7 units from 0 on a number line. Well, if that's true, let me draw a number line. And here's 0 on a number line, here's 7 on a number line, here's negative 7. That means that what's sitting right here at 7 is x minus 4. And what's sitting right here at negative 7 could also be x minus 4. Because x minus 4 is supposed to be 7 units from 0 on a number line. And that means that I can write this as 2 separate equations. And I'm going to write this as x minus 4 equals positive 7. Or x minus 4 equals negative 7. And so in this case, I'm going to add 4 to both sides, and I get x equals 11. Or if I add 4 to both sides here, I get x equals negative 3. So those are my 2 solutions for this problem. All right, so that was like an Algebra 1 kind of an absolute value problem. Let's try an Algebra 2 kind of absolute value problem like this one. So in this case, I've got absolute value of x squared plus 6x equaling 3x plus 18. Again, with an absolute value, you're going to set up two equations with the word or in between them. So let's say our first equation is going to be that x squared plus 6x equals the 3x plus 18. Or the x squared plus 6x. Remember, we never change this. We don't take the opposite of it. We just never change that part. Right, so that's why I'm writing x squared plus 6x just like I saw it inside the absolute value. But this time it could equal the opposite of the other side of the equation. So it equals the opposite of 3x plus 18 in parentheses. So I better distribute this negative, so I get x squared plus 6x equals a negative 3x minus 18. And I want to solve this equation. It's probably best to get everything over on one side. So I don't know why I'm starting with this one on the right instead of the one on the left, but let's just deal with that. So I'm adding 3x to both sides, and I'm adding 18 to both sides. So it looks to me like I've got x squared plus 9x plus 18 equals 0. Does this factor? Well, I think it does. You could do product sum, or if it's jumping out at you, I think I'll have x, and I'll need 6 here, and a 3 here, and a plus, and a plus. As a check, x times x is x squared. Outer terms is 6x, inner term is 3x. That adds up to 9x, and then 3 times 6 is 18. So I think that that looks good. And then my two solutions over here, when I set these equal to 0, I would have x equals negative 3, or x equals negative 6. Oh, so far so good. Let's solve what we have over here on this side. So here, if I subtract 3x from both sides and subtract 18 from both sides, I'll have x squared plus 3x minus 18 equals 0. Does that factor? I think it does. I think this factors into, let's see, x here. I think I still need a 6 and a 3, but I want it to be x plus 6 times x minus 3. Again, you can use FOIL to check me on this, and you can certainly do product sum to do this if the two factors did not jump out at you with guess and check. So in this case, I'm going to set this equal to 0 and this equal to 0. And I'm going to get x equals 3 or x equals negative 6. So overall, it looks to me like I really just have 3 solutions. And my 3 solutions are x equals 3, x equals negative 3, and x equals negative 6. Those are my 3 solutions. Because this guy actually turned up twice, right? Turned up on the left equation and on the right equation. All right, so that's it for this video. Thanks for watching.